So thank you so much. Ooh, announcement from Zoom. Thank you so much for inviting me. It's really nice to be a part of the Calgary community. I've never personally been to Canada before, but my two best friends are there and they're in New Brunswick, and I hope to visit, permitting COVID, one day. So I want to preface that I am not an expert with package development. I only started learning this stuff earlier this year when I was hired as an R packages developer. They wanted someone with a biology background, so here I am. So I'm still figuring out lots of challenges when it comes to package development, but I also want to preface and say that learning how to make an R package is an incredibly rewarding experience. And it's particularly fun if you do it as a group because it's less overwhelming and you don't have to do everything by yourself. And I hope that's it's a skill that you guys continue to develop after this workshop. And so I want to give you guys a quick overview of what I've prepared for the workshop. So if we go to this link, it will take you, I might be able to click, command click, shift click, control click. I'll just show you on the web page. If we go, this is the GitHub that has all the materials for this workshop. So you will scroll down and there's an overview, some of the prerequisites that you need. So I just recommended everyone have R and RStudio installed and 3 packages that installed in their R library. And if you'd like to download the contents of this workshop, you can go through into this using this green button and go click on the green button and just go download zip. And that will go straight into your downloads folder. And you can unzip that wherever you want in your computer. Alternatively, you can clone or you can fork this repository. This repository is on the MIT license, so anyone can take its contents and do whatever they want with it. So we'll be mostly working from this file, mainsfunction.rmd. But instead of you having to open this RMD while trying to code and making this R package with me, I've rendered this into this website. So if you just click on this button, it will take you to a knitted HTML that has all this stuff that you need for the workshop today. And I've included these copy code, like you can very easily just copy the code inside these code boxes and paste it into your RStudio console or your R console, just to make it easier for everyone. Great. Any questions about accessing materials before I get started? I will try and monitor the chat as best as I can, but if I'm not paying attention, please feel free to unmute and just shout at me to get my attention, or maybe Chell can help me with multitasking when it comes to answering questions. Let me see if I can. So now, let me share my screen and pivot to RStudio. Oh, I'm unable to load Clippy. That's okay. Would it be okay for you to just manually do the copying and pasting for the workshop, Robert? That should be working. That's okay. Yeah, sometimes it's more just different R versions, updates, and various dependencies. Sometimes not all the best functions are available, but manually copying and pasting is okay. Great. Let me pivot back to my slides before I begin. I think we should just quickly define what an R package is. But all as R users in this community, I would assume we're familiar with using the function library and calling some sort of R package that we need for whatever purposes that we need. And so in a very broad definition, an R package is something that has code and or data and some sort of background tests that's all bundled together into a downloadable unit. So this is a very basic definition of an R package, and that's something we will be making today. And it's possible that we can all make one. But I think before we jump into making one, it's probably a good time to discuss why we ever want to make an R package. And feel free to slowly, everyone can share their thoughts in the chat, or if they feel comfortable, definitely unmute and have a chat with me. Maybe we'll just spend a couple of minutes on sort of why we want to create an R package, what are the good attributes of an R package, and anyone here that has any experiences developing packages themselves. Yeah. I'll wait a little bit until people warm up. Yeah, great, Zane. I'm not sure if I'm pronouncing your name correctly. Building 2 packages, that's a lot of work. No experiences yet. Certainly don't need experience to attend this workshop. So that third point is more just, I was assessing the crowd. We've used lots of packages. What are some, attributes of a really good package? For me, my favorite package, favorite package is difficult. Maybe ggplot. I think it's very intuitive. Great documentation. Ooh, data table. Easy to use and understand. Absolutely. I think that's sort of so those are really important points. And I think Tidyverse have embraced the verb, the grammar of making functions, so that all functions are very intuitive. Ooh. Fantastic. Okay. Any thoughts on why we want to create a package, other than it's a good thing to put on your CV? Yeah. So for me, why create an R package comes back to this tweet that I came across it a while ago. And this person, David Robertson, said, "I wish I'd left this code scattered across different R scripts instead of combining it into a package," said no one ever. So I think the point they're trying to make is that an R package is a very great way to organize your files and to be able to share it. And like Jose said, it's a great way to replicate an analysis. Ooh. Or to reproduce an analysis for a particular study or report. Oh, I don't know what goat means. Is that what? I'm just reading Zane's chat. Anyway, so here are some of my kind of the pointers that I've summarized why it's a great time to learn to make an R package. Safeguarding your future self is probably my best thing, the best point. That's something that really resonates with me. Often I have to go back and I said, in my brain, I know I've somewhere filed, I've made this, I've written a function for this before, or I've done this before, but I just can't remember where. So writing your own functions and having a good documentation system can really alleviate that mental space and remembering where things are kept. Because lots of R packages are hosted on GitHub or even on CRAN and Bioconductor, those sources, they make R packages, the software themselves, really easy to share. So everyone that has access to a computer and internet is able to access those tools, which is really great. Again, it's more like tidiness, sparking joy, everything's organized, you know exactly where things are filed. But I think the 2 lesser known benefits of making an R package is improving coding and function writing skills. And finally, it opens door to contributing to other packages. This final one I didn't realize was a thing until I started writing R packages myself. I was trying to use a function from, I can't, off the top of my head, I can't remember. I think it was somewhere from RStudio. I think it was a tidyverse function. And something wasn't right. Even looking at all the help files, Googling, Stack Overflow, I tried my best to make something work and for my own purposes, and it didn't work. So I decided to write a, minimal reproducible example and then post my first GitHub issue, which feels very terrifying because, you're lodging an issue. The idea of an issue feels so scary. But not only did that issue get kind of escalated to the higher developers, they were like, oh, this is an actual bug in our infrastructure. We'll take, your feedback on board, and we're going to, release it in the next feature. So while you're writing your R packages, it helps you understand sort of all the infrastructure that goes into making something like a tool. And it also helps you then, give feedback on other people and receive feedback from others. So it's just a very happy place and welcoming community to be. Great. So a little bit about, I like writing my workshops in a way like MasterChef. I'm a MasterChef fan. And often chefs talk about their mise en place, which is like all the things they need and everything they need to prepare for a cook or for a meal. And so these are some of the packages that you'll definitely need for creating your first R package. Mostly DevTools and use this, they're just amazing. I do most of my software development and package development in RStudio. The interface is really handy, and it's handy to sometimes have Git there if you use Git for version control. These are some, I would consider that these two packages would make kind of the basis of your package, your plain cake. And then these other packages down here, the 4 packages, are the extra things that you want. If you want really nice documentation, Roxygen 2 is a really reputable package that I suggest people to adopt. testthat for writing unit tests, which we'll talk a bit more later. And Hexsticker and package down just I would say it's the cherry on the top of your package. And it's nice to have a very beautifully made Hexsticker that you can print out and share at conferences or at work. And package down just basically renders your entire R package working directory into a very beautiful website, so people can navigate and access your vignettes a lot easier. So although Git, we're not going to be really touching on Git and version control today, but if you are able to, in your own time, integrate the use of GitHub in your development workflow with R packages, it really makes your life a lot easier. And not only it's a home for your package that people can go and download, and it provides version control, all those basic benefits of Git, but GitHub has also released this thing called GitHub Actions, which can continuously integrate testing for your package, or rendering websites, or rendering readmes. So those just additional add-ons with using GitHub with your R package developing is a game changer, but that is for a different workshop, and maybe I'll write that in the new year. So today we will make our own R package together in this workshop. We'll add a license to it, because licensing can be very important when it comes to creating software and intellectual property. We'll create a function. I hope you and add that to a package. We'll document it. We'll create a README, which is a really important landing spot for whoever wants to access your package. We'll create a vignette, and finally add a test for our function to ensure that it's working properly. So we will be using these packages, and I think this would help us make the kind of bare basics, minimal viable product in terms of an R package. And this is the package we'll make. We'll be making a Whaley together, and this is something I wrote specifically for this workshop, because everyone just creates an R package that's like calculating a standard deviation or standard error, but I wanted to create something fun. So a Whaley has a single function called say, and it just spits out whale puns for everyone to enjoy in their R console, because that's something we all need, especially during these COVID times. Okay, without further ado, and let me check if anyone has any questions before I bounce into R. Are we all happy for me to move on? Let's see.
Yes, thank you.
Great. I don't see any raised hands, so I think we're good. Great. Can everyone see my RStudio? I am assuming we're okay. Great. I can see thumbs up. Fantastic. I'll put this on history. Let me clean this up. So we will need this devtools package to create our R package. So this will also in the background load use this as well. So it's just everyone go ahead and call devtools. And if there's no complaints, we will use a function to create our, the package infrastructure. So before we do that, I just want to, preface and tell you guys just to be intentional where you place your R package, whether that's going to, it might put it, if you don't kind of navigate to where you want to put it, it might just put it in your root directory, which is just kind of like the base of your computer. I personally put mine just somewhere in a folder called R. Sometimes I put it in Dropbox. So wherever you want to create it, just be intentional where you want to create your R package. So to create your R package, we are going to use this function called create package. And we're going to call it O'Whaley. So you go ahead. Because my R is set to the root directory. So it's just created in my root directory. If you are within a folder somewhere in your computer, it will complain and it's just R, it will just let you know, are you sure you want to create your R package there? So running this function will actually open a separate R window. So it's created a separate window for me. And it's set the project as the name of my package. And just, so that's a good way to check that you're in the right window. So if you run that create package function, just check that you are in the R window that has O'Whaley on the top right-hand corner. Great. And because it's opened a new window, we have to load devtools again. And because later we'll be writing some tests for our function, we're going to also use testthat. So I'm just going to preload those so I don't have to forget. Oh, sorry, Chai, I don't have devtools. Try installing it. I'm not sure. Maybe check your internet connection if install.packages for devtools can't work. I don't know if DevTools has a GitHub that you can install directly, but no worries. You can definitely catch up because all the code is rendered here, so you can definitely catch up and copy and paste. I'll go in an easy place. Good suggestion, Zane. So now that we've created this is the basic skeleton of our R package. Let me walk us through some of the files in here. So we've got an R build ignore. This is, if you've used Git, it's very similar to your Git ignore. This is just syntax that what you put in your R build ignore basically doesn't get placed in the R package that someone else can download. So it's just ignoring things like the .user file and the rproj file, because we don't want that to be exported to any user that downloads the package. Your git ignore file, again, it's just ignoring the rproj user file. I think the most important thing in the R package skeleton is probably your description file. So this is where you kind of tell everyone a bit about the title of your package, what it does, what version it is, the authors, et cetera, et cetera. This is also the file where you specify dependencies. So a dependency is when, say, I want to write a function that uses mutate from dplyr. So this is where I would, the description file is where I would say and declare, oh, O'Whaley uses mutate. So when someone downloads O'Whaley, it also automatically downloads dplyr if that's, and loads it if that's not on their computer system. But we'll get to that for now. We'll just briefly show you around. There's also a namespace. This is, you can't edit this by hand. We edit it via changes in description, which I'll also show you in a second. The namespace controls what functions you want to export to the user and what function you import from other packages that you depend on. So a namespace is also important, but because it's so closely related to the description file, and this is the file we'll be using the most. The function also created an R directory, and this is where you put in any functions you want to include in your R package. So let's go ahead and edit the description file manually. So make yourself an author. So change the first and last name. I'll just delete the email. And so we are contributors and we're also the author. I don't really want to include my author ID in this case. So let's also talk a little bit. What does the package do? So here I'll talk about echoes whale-shaped messages in console. Please feel free to add whatever you want here. At this point, it's not super important because this is a package that we're making together. Description. Again, I'm just going to copy what I have in the title. Great. I'm just going to save that. So it says license. And the great thing about developing your package using DevTools and within RStudio, they provide really helpful prompts. So instead of manually editing this license bit and including a license file in our files, it's say, why don't you use this function, either of these functions, or pick a license that you want to create. So let's go ahead and use this MIT license to declare this license for this package. And again, you have to put your first name and your surname. So it's done various, the function's just letting us know, whoa, okay, we've set the license field in the description file. So that just got populated automatically, and it's created these license files within our directory. And it's added these files in the R builder more. It's all just happening and done for you automatically, which is great. How's everyone doing? Everyone following along so far? We're just getting the boring formalities out of the way. I think we're good. Okay, so far. Fantastic. Great. So when you're developing your package, often you want to just make sure things are running correctly. And so you want to check it. So the function is to check your R package can build and get installed and to be used is check. So we're going to use this function every once in a while just to make sure. Oh, it's complaining that I need to put an email. Okay. In the interest of saving time, that didn't really help me. Hey. Great. Let me save my description file and run check again. Check file, okay. Choose given instead of middle. Sorry, guys. Classic. There's no as a maintainer. But this is my email. What was it before? Sorry, guys. Live debugging. It's been a while. I'm just gonna undo everything I've done. Yeah, I feel like that's fine. What's my package do? Whale messages. This often happens. Let me run check again. I don't know what's going on. Gives no person with maintainer role. I believe this is maintainer role. Is everyone getting the same error? Oh, this has never happened before. This is a valid email address. check. Please check. Please pass my check. That's very strange. Yes, we want what Millie is doing. 0 errors, 0 warnings, 0 notes. I'm not sure why. Let me just maybe. I don't know why it's complaining. Sorry, folks. Give me 1 second. Something wrong with my authors. I don't see anything wrong with mine. Can anyone spot anything-ish wrong? It's recommended to use given instead of middle. I'll use what Chill did. Let's see. Copy. Sorry, folks. That is so strange. Okay, we can still go continue. Without this passing a check. Yeah. Because this should work. This has no, maybe if I go author. Yeah, check. Yeah, that's all right. Let's move on. Well, when your computer's working and when your description file passes those checks, you should be getting 0 warnings, 0 notes, and 0 errors. And often when you do run the checks for your own computer and your own packages, that's often the goal that you want to achieve. Errors, the general rule of thumb is you really want to fix your errors. Warning and notes are okay, but you want to keep those to a minimum. And often the check function will provide really helpful guidance on what's kicking up an error or warning or a note. And it often points you to a link or to a documentation online to help you resolve those messages. I believe if you want to submit your package onto CRAN, you have to, everything needs to be zeros. So that's a goal to work towards. Great. Let's move on and write our own function. So to write our own function, we're going to use the, we're going to write our own function, but because the function we're going to be writing uses the pipe, I just want us to declare using pipe in our package first. So everyone, let's go ahead and run this function, use pipe, because I want to illustrate this using the pipe imports the pipe from the Magritta package and it adds it into our description file automatically. Remember how I said the description file is where you specify your dependencies? This is how that's done. You can also do this manually, but the use pipe function just did this automatically. So now the function's prompting us to go run the devtools document function to update the namespace. So let me open my namespace. Note here, this is empty. So let's go ahead, everyone, and run document. Document basically goes through all your files in here, especially your description file and any vignettes. And it's going to scan through all your files and say, oh, it's actually importing a function from this package. We're going to make sure our namespace corresponds to that import. So let's run it. And you're going to see, oh, okay, this package imports from Magritta the pipe, but it also exports the pipe. What that means is when anyone goes library or Whaley and loads this R package, it also automatically loads the pipe as well. Does that make sense? Okay to move on? Great. So now let's write our first function. We're going to go use R. This function is for creating an R script file for us. And the name of our function is called say, S-A-Y. So within the R directory, it's created an R script for us called say So let's go ahead and edit. So right now it's currently empty, and this is where we will put our own function. So on the website, I've rendered, there's a bit of code I'd like you to copy and paste it into here. It has a whale in it, and I can walk us through what this function means. I did not completely author this function. Definitely have borrowed it from another package called cowsay and praise. This package is definitely heavily inspired and borrowed from those packages. Here I'm in these first couple of lines is me just defining the ASCII notation for a shape of a whale. You'll notice here this %s is in this block of code, and this %s is really becomes important below here. So here I'm just using some regular expression to determine the position where %s is, and this is where the personalized saying will be inserted. And this function also, if the user doesn't supply a text string, a character string of some sort of phrase, this function will go into something called phrases, a file called phrases, and then just sample a random phrase, and it assigns it into something called what. And then these final lines is just stringing all those together, stringing the whale ASCII, the personalized phrase, the what argument, and completing the rest of the whale image. And it returns the output as a message in the console. So go ahead and save that. And because, as I said, this function depends on something called phrases, we are also going to create another R script called phrases. So go ahead in your console and go use R and go phrases. So that creates another R script in our R directory, an empty script, which will populate with some whale puns. It was whale season here in Sydney, so this was why I decided to make a whale themed package. They were coming back from their migration to the north. So paste in the phrases here. Feel free to add whatever phrases you want and go ahead and save it. So now our first function is done. And to take this for a test run, we're going to load a preview version of our R package. And to do that, we're going to use the load all function. So that just, instead of installing it from scratch, it just goes through our R directory and loads everything as a preview. So let's type say in the console and see what happens. If everything went well, a whale should pop into your console. I will wait for thumbs up to make sure this worked for everyone. Yay, great, everyone's got whale. So you're welcome to put in your own message. Great. No complaints so far? Great. So within the website HTML, I've included various tips and extra bits. Although that stuff is not technically part of this workshop, because then that would make the workshop a lot longer. Do recommend you taking a look at that stuff in your own time. For example, there are extra bits and pieces. Say if you want to write your package with tidy evaluation. By that, I mean typing out a variable name without actually having to put it in quotes, which a lot of functions require you to do. Definitely take a look at the extra sections. It's just additional ways to level up your R packaging developing skills. So next, let's talk about documentation. So we're going to document this function now. And so by documentation I mean, like, let's look at the help file for check. It's when you call the help file you will see this nicely rendered documentation in the help window. So we're going to be creating that for the say function. So to do that, we're going to go back to, we can close phrases, go back to say, and we're going to be using Roxygen2 to be doing the documentation. So I've created a template in the code provided, and you're welcome to copy and paste this directly into your function just above it. So you can go copy, let's go and paste it. Let me walk you through what this kind of interesting notation and what these blue bits mean. So Roxygen, I don't know the technical details, but it's just a different language that starts with a hashtag tag notation. These blue parts are called tags, Roxygen tags, or they also call them rocklets. But these are just values in the Roxygen package that specifies what is in your function. So @param stands for a parameter or an argument of your function. @usage is basically kind of the syntax of how you write out your function if you were to use it in the console. @return is where you specify what the function returns, a well-statement message. @export is probably the most important tag here because this tells R that this function gets exported when the package is built by another user. And @examples is where you include some examples of how you use the function. So yes, you can copy the Roxygen template into the say.r. Alternatively, if I delete all this, you can do this manually. So if you place your cursor, so inside the curly braces of the function, and you hit code, and you go down and go insert Roxygen skeleton. This only works in RStudio, I believe. It will also include create that template for you. So there are two options. You can do that manually by putting your cursor inside the curly braces and go insert code tab and scroll down and find the insert Roxygen skeleton, or you can paste it directly from the template that's already provided. Great. So hit save once you've documented the save functions with whatever you want to put in the title and how you want to describe your parameters. To make it go live, you use the document function again, because we need to tell the R package, oh, we've just made changes. Can you please make sure these documentation is updated? So let's go ahead and run document. So again, it's telling us it's done various things. It's updated the documentation, it's updated the namespace, and it's written these r.rd files. These are the files that get rendered in the R documentation window. So let's call the help file for say and see if that worked. Ta-da! That should work for everyone if everyone included some Roxygen documentation in their function. Oh, wait, please call out if that didn't work. So there are lots of other Roxygen2 tags. So one tip is if you hit enter, you start typing the like a lot of functions in RStudio, it gives you a drop-down list that you can scroll through, that you can explore. But these are the basic ones. The ones that's included in the template are the most basic ones that you can use. But if you, for more fancier R packages, you can definitely make use of these other Roxygen tags. Great. Hooray, I'm glad that's working. No complaints so far. Let's move on to editing our README. So our README only becomes really important when it's hosted like that's the first point of contact when it comes to downloading an R packages from GitHub. So and README, for those who may not be familiar, is the very first, this file here that gets someone's attention on the very first homepage of your GitHub repository. So it's kind of where you want to put all the most important information you have for a particular R package in this case, to help people navigate through. Great. So in order for us to edit our README, we're going to use the function called use README underscore RMD. So that's R Markdown. So you'll notice there are README. There's two README functions. There's underscore Markdown and underscore R Markdown. So in most cases, you'll probably be using the R Markdown version, just because typically in an R package README, the README often has a installation instruction, which is R code, and maybe some demo, like a quick demo of the of the R package, which is typically also in R code. So using the R Markdown version just allows you to write R code more seamlessly without having to toggle between Markdown and R Markdown language. So go ahead and call that function, and it's going to create an R Markdown README in your directory. So great. So now let's edit this manually. I've, for the purpose of this workshop, in the GitHub repository under templates, I've created these templates for you that you can immediately go into and copy and paste, because I don't think I can live code this without making any mistakes. So go ahead, copy and paste the contents of that example README and paste it in your readme.rmd file. It's just telling a bit about kind of the origins of the package. You know, installation is often the most important thing to help users, to guide users through that process. Here, I'm just giving a very brief demo of the package, but in most cases, your README is up to you how you want to customize it, but those are, installation is probably, I would say, the most important prerequisite of a README. So once you've got that in your files, let's save it. And then we can't knit it right now because this README calls O'Whaley. So before we knit it, we have to technically install a hard copy of O'Whaley on the computer. So to install a test version of your package, just use the install function. Oh no, this won't work for me. I just realized because my description files is complaining. Let me see if I can. Well, for the purpose of illustration, I don't think I can show you. It should install for everyone. Recently I deleted R by accident on my computer, so I think it has something. The error might not. The error is happening for me, but in your case, I think it should be working. For example, Zane, install worked. If install worked, go ahead and click knit. I don't think knit will work for me. Oh, it worked for me, but it's complaining that the great. So go ahead and try knit your README. This is your README. Fantastic. Oh no, what error did you get? Knitting is always a bit tricky. Oh, let me see. You can copy and paste your error into the chat and I can have a quick look. But with the interest of time, I dropped the O part of the name. Okay, great. I'm glad it's working now. Great, with the interest of time, let's move on. Now that we've created a README, we're gonna go and do some long form documentation. And by that, I mean, look at the create a vignette for this package. So whenever we've kind of come across a new package, we often look at for its vignette. For example, there's a vignette for tidyverse or dplyr. This should work. Oops. Ooh, I spelled it incorrectly. Ooh, I've just called the help file. Excuse me. So it's basically just additional, more in detailed help, your vignette. Often it kind of really walks through a case study using some example data, and really among the text, and the text would explain what the functions would do, as well as kind of showing you the other utilities of the function. So we're going to be creating an one of these for O'Whaley. And like all the other functions we've been using so far, that's been very intuitive, we're going to use the use vignette function. And we're going to put O'Whaley as the in a character string, because that's the name of the package. So our first vignette should be named after the package. You can create as many vignettes as you want. Some people might have one for kind of explains the background or the mathematical calculations if it's a heavy, modeling sort of package, or if it's a more graphics based one, they like to include the theory or the kind of language use behind the naming of the functions. Other people like to include a contributing guidelines just to help people format the pull requests if they were to make any changes in a forked repository. Anyway, so the use vignette function adds this .rmd inside your, creates this kind of vignette directory, and it puts the RMD in there. So we're gonna, in the GitHub repository, there's the example vignette, and for the purpose of this workshop is just exactly the same as the README, except for the YAML atop here. The YAML on top is different. So go ahead and copy, and let's paste it into the O'Whaley RMD file and save it. And it should knit. So go ahead and try that. Oh, yes. So yes, I can repeat that. So if you hop into the GitHub repository, under templates, there is a template called example vignette.rmd. Click on that and copy the contents and paste that into your O'Whaley.rmd, which should be automatically opened after running this. So go ahead and paste it into this file and save it. Does that help? Great. Great. So in order for the package to build the vignette, though, we have to use the build vignette function. Once you've saved it, it's just going to go through and read this RMD and build and render it into a nice format. Although, because I'm having problems with the description file, this may not work for me, but it should work for you. After running build vignettes, also run the document function just to be safe. And to get a preview of your vignettes, use the function either, if you want to preview the vignette in just this help window or this view window, you can just go vignette O'Whaley. This will fail for me, but if it built correctly for you, it will take a couple of seconds. this should pop up in your viewer. I'm sorry, guys, that my description file isn't working. How strange. I'll fix it later. So let me know if you have been able to successfully build your vignette for this package. We're almost there. Just waiting for Zane. They've been very helpful in giving me feedback. Yay, okay, it worked for Jose. I'm great. I'm grateful. I'm glad. Just wait for a couple. If you want to, you can also use the browse vignette function. This one, instead of previewing the vignette in the viewer window, it opens a new tab in your default browser, and you can view the HTMLs there. Oh, failed. Let's try going through document, build vignette and document again. Yeah, but we can keep going, because the last component of our R package building experience today is we're going to be writing a unit test. So this is probably the most tedious and most complicated part of developing an R package. It's always fun creating the functions, but testing the function is a bit tricky and requires slightly bit of a backwards abstract kind of thinking. So the tests are super important because it ensures that the function is, the package is working and functional, and that it's functional on my computer, on your computer, on whoever's computer, whoever has downloaded the package. So first, to write tests, we're going to use testthat. Let's use type this function. Yongping, I think Chael has recorded this, and and everything's online, so it'll be okay. We'll catch you up. So go ahead, everyone. Let's go use testthat. This function just declares in our description file that we're using the testthat function to do our testing for the R package. I just want to quickly pause. There's some horrible construction happening outside my window. Is that obstructing the recording by any chance? Please let me know if you can't hear me. Okay, great, fantastic. It certainly sounds very loud here. Okay, so let's write our first test. We'll use the useTest function, and we're going to type in say, because that's the function we want to test. So this creates a tests directory, and within that, a testthat directory, and within that, an R file where we can specify our tests. And it's included a very basic template, which has nothing to do with our function per se. So we can delete that. So let me, before we write our first test, I sort of kind of want to talk a little bit about the formatting of this testthat. So tests are organized in these groups. It tends to often, depending on the function that you're testing, it tests a very specific part of the function. That's why it's a specific unit. So tests often are very isolated in that way. And so that you know you're testing a very specific aspect. And by a specific aspect, I meant you're testing the output comes out correctly in the correct format and has an expected class or structure that you wanted, or the calculations are exactly within some degree of tolerance, is within the ballpark that you expect. So tests are for dedicated functions of your package. So often you have to write them in this format, starting with the testthat function. Here you have to include just a brief description of what your test is, just to make sure, so it's easy to kind of hone in what test is failing when it does fail. And you have these curly braces then, and within the curly braces is where you specify your expectations from your function. So often these expectations, your tests are consist of these expectations, and there are lots of different expectations. So if you type expect underscore and then click tab, there are all these expectations that you can use for your tests. So for example, let me use expect equal. And on the first argument of this expect equal function is the actual thing that you want to test. So for the purpose of this workshop, we're testing the function say, and the expectation, what do I expect the say to spit out? And that is that would match the match say. So in this, expect equal doesn't actually work in this in this context, but often I just want to make sure people understand that on the first argument is the actual thing that you want to test, and on the left, the second argument is the expectation that you expect from the function. So within the template code, I've included some examples, and these would be a bit easier to understand rather than that, what I just tried to do. So this particular unit test is testing if the output is in a correct format. Yes, absolutely, Pablo, I can do that. After I go through these tests, I can spend a couple of minutes on looking at the skeleton from the root of the project. I'm using 4 expectations here. Expect length. So I'm testing the function. When I call say, like it returns as a message. So if I go say and I assign it to X, and I go length of X, it should still be 0 because it's constantly returning as a message. It's not, there's no global, like my environment hasn't changed. So let's try, so that's why expect length. I'm expecting the length of what say returns is going to be 0. So expect null, I expect it to return nothing. By that I mean like there's nothing in my global environment that's changed because it returns invisibly. So again, expect invisible is intuitive. The function does it invisibly. There's no direct changes in my global environment. And finally, expect message. I expect say to return as a message, which is often in red in R. So go ahead and paste that into your test say script and save it. And you can run this manually, this unit test manually. And you'll see it kind of runs, say 4 times, and it tells you, oh, your test is passed, and it gives you a happy emoji, and it's all in green. It's all very happy and positive feedback. Or alternatively, you can click on this test, run test, and it will run in the build window, and it will tell you the test is complete. And if your check is working, if you run check, it would go through the package building and check all the packages in correct format. And it will also, at the end of the check, it will also run those tests for you. So those are the 3 ways that you can test your package. But because my description file isn't working, but Chill has given me a template to put in, hopefully this will work. I don't think I need 2 of these. Okay. Let's see. So go ahead and see if you can run your tests. Check now. Jill has fixed my R. Thank you, Jill. So the check will run through all these kind of background checks, as well as the testing script that we just created. And it should be all returning with 0 errors, 0 warnings, and 0 notes. We want all green, which is what's happening here. So if that is happening to you guys, let me know. Let me know if there's anyone having any problems. But that's, in terms of the interactive part, that's all today. Ooh, package build check build tills debug is my error. Ooh, Sonia, I think you may have not created a phrases R file. So if we go back to, I may have gone through that too quickly. So within my R directory, there is my say function, which we copied and pasted, which I believe you have. But because say calls for phrases here. So I've also created a phrases.r file where I've included just a big long vector of whale phrases. So I think that's missing from your R package, Sonia. I'm not sure what's happening with Zane's. Check build tools. That's something I will have to Google. I suspect it might be a dependency thing. Any other questions while I try and Google Zane's error bug? Seems like a recent Big Sur Mac issue. Might be an RStudio issue too. Sorry, Zane, I'm not sure. Yeah, it keeps wanting a third party to be installed. Bugger. If you go in the build tab, Zane, and go check, does it give you the, if you hit check there, I think this does it in terminal. So it bypasses RStudio, although it's printing in RStudio. Try this way of checking. If that works, then you don't necessarily have to do it within the R console. Great. That's all, folks. But maybe I'll quickly show you guys. Within the this HTML, there are these extra bits within this document. Say this bit is including, say you want some test data. This code here you can unhide, and this will teach you how to include some test data in your package and how to document that data. But I suggest doing that in your own time. Oh, I'm sorry, Zane. I'm not sure why. My way of debugging errors like that would be like updating my RStudio, updating R, updating all my packages, and then trying it all over again. But this looks like a recurring issue for many Mac users. Okay, great. Does anyone have any questions for me before we wrap up? That's good. I hope everyone has a whale in their console now. No worries. Yeah, that GitHub link would be helpful for anyone that is revisiting the recording as well as doing this workshop in their own time. Great. Do you have any concluding words, Chell?
This is just amazing again.
Thank you so much for fixing my description file, by the way.
No, I just read the manual again.
It's always running, live coding always is a barrier to like efficient debugging.
Okay, so any other questions?
No, thank you.
If you have any questions, please feel free to email to Dr. Kar. She's very nice to respond.
Yes, definitely.
No.
Definitely reach out if you have any questions. And for the part of pushing to GitHub is the part I use the browser, not terminal. Zane. Yeah, GitHub. I didn't want to set up GitHub for package development because that everyone uses GitHub differently. I use the terminal. Some people use the, there's a Git tab if you use it in R. But I've included some helpful resources into the HTML about how to set up Git. I believe someone, might even be Jenny, Ryan, they had written a really nice blog. I think it's called Happy with Git R. I definitely recommend looking at that and looking at how to set up Git in a way that helps you the best. Yeah, I think Jenny has a great book. Great. Well, I don't want to take up any more of everyone's time because it's hungry and it's cold.
Thank you very much, Dr. Kar.